lost. What would be the future? Could you pay the cost? You wonder, will there ever be a second time around?
Oh, hi there. Welcome to CE 291 Lab. This is the first introductory video to the DAQ portion of the class. So why don't we start by looking at what's at our lab stations. So as you can see, I'm typing here at our super fast computers. And each lab station has its own wooden shelf that has all the materials you'll need to be a successful student in this lab. Up on the top shelf here, we have our multimeter, which will let us measure voltage, amps, and resistance. We have our resistance substitution box, which will let you make any resistor you want. We have in here our little box of goodies that has all the cables and cords to connect to the multimeter, to connect to some of the other things. In here we have a microphone, which we'll use later in the class. We have our power supply, which will let us set voltages and currents. Right here we have our data acquisition device, which will let us record data. And then finally over here we have what we're calling our central signal ports that will allow us, the TAs, to send out some voltages to you. You can plug your cords right in here and record what we're sending out. Alright, so the first instrument we're going to look at today is the digital multimeter. And as I said previously, the multimeter can measure voltage, resistance, and current. And that depends on where you plug in your inputs to. And so if we look here, we see voltage, resistance over here, and these ports over here are for amps. So what we have to do is plug in our test leads, which are these two probes here. And so the black probe always gets put into this port labeled COM, which means common. Okay? So if we want to measure voltage, we look at to see which port we have to plug into, and we see that the V right here stands for voltage. So then we can plug in our red lead into voltage. Okay? So one thing to remember is that black is always negative, red's always positive. So we turn the multimeter on with this orange button here, and it reads out something very small, 10 millivolts. And if we want to measure the voltage of this battery here, we need to take the black test lead, touch it to the black probe of the battery, and the red test lead, and touch it to the red probe of the battery. And we see that the battery measures 6 volts, which is what we expect because it is in fact a 6-volt battery. Now, if we want to look at resistance, we have a resistor right here, and we have to rethink at how to set the multimeter up. So we look at what port we're plugged into, and we see here that we're in the resistance port, but we also have to check this dial. Before we are plugged into the voltage, we have to switch the dial to this ohm signal, which means resistance. And to measure the resistance, we simply put the test leads at both ends of the resistor, and we see that it is a 10 kilo ohm resistor. Finally, if we want to measure current, we look down at the ports again, and we see 10 amps. Amps is a unit of current, so we have to switch our red test probe into this port. And then if we look on our dial, we see amps over here, so we have to switch our pointer all the way down to here. Alright, here we have our DC regulated power supply, which will let us output a current and a voltage that we specify. Over here we have the power switch, so let's turn it on. And you can see on this display we read out the voltage, and this display we read out the amperage that's coming out of the power supply. And those are set by these knobs right here. If I turn this, I can turn the voltage down or up. And the current, similarly, since we don't have anything drawing current right now, it's not changing. But if we did, we would plug it in right here, our negative port and our positive port, black and red. Our power supply also has the option of outputting a constant voltage if we plug in right here, we get 12 volts at a half an amp. And if we plug in over here, we always get 5 volts at a half an amp. So here we have our data acquisition device, which allows us to record voltage and record it on the computer. So you'll see there's a lot of different ports that have screws on them. What we're going to look at are these analog channels. Each analog channel has a positive and a negative terminal you can plug into. And what we're going to plug into these terminals, we pull out from our box and we get our banana plugs here, which we have a positive and a negative, and they have bare wires at the end to plug into the terminals. We also need to take out of our box our screwdriver and then plug these into the data acquisition device. So we start by loosening up the screws and then plugging in the bare wire and screwing it down to keep it in place. And again with the other wire, we do it at the other terminal. And so now we have our leads plugged into the data acquisition device, and we have to record by plugging these in somewhere. In this case, we'll use the central signal port, so the positive goes in red, negative goes in black. And as I said before, the data acquisition device interfaces with the computer, and we'll be using MATLAB, which we'll show you next. Alright, so here we are in MATLAB ready to acquire signals from our data acquisition device. We're in our directory for our class and our section, and we're going to use the program called DADAC MATLAB. And so the first thing we want to do is look at the help file for DADAC MATLAB. So we type in DATAQ MATLAB, and we see all the input and output parameters for the function. So we see here's the top line of the function. We get returned data and time, and we type in the function name DADAC MATLAB. We have to give it sample frequency, duration for which to sample, and then a V range, so what voltage range of the device we want to use. And all these parameters are defined down here, as well as the outputs. So let's go ahead and use the program. So again, looking at the help file, the first thing we type in is data and time. These are our output variables, equals DADAC MATLAB. And let's sample at 100 Hertz sample frequency for a duration of 10 seconds, and you can see you're getting highlighted down here, and then over our default voltage range of 10 volts. And we'll suppress that with a semicolon and push enter. And MATLAB starts recording right away. This is the real-time data that's getting acquired. You can see it's kind of a sine wave, and we're almost done. And then MATLAB returns a plot for the entire 10 seconds, and we see here's our sine wave. And if you remember, we recorded at a frequency of 10 Hertz for 10 seconds. So if we go look in our workspace, the variable data is 1,000 elements, which is 100 Hertz times 10 seconds, and the same as time. So our voltages are stored in data, and again, our sampling times are in time. Alright, so as a general overview of the first lab, what we're going to be doing is going to use the multimeter and the data acquisition device and look at a couple signals, record them, and use that data to analyze the sampling frequency, the resolution, as well as the accuracy. And then at the end, you'll have some time to play around with circuits and look at Ohm's law. And if you follow the directions step by step, you should be just fine.